Okay, so my problem was 2007, Form B, question number 2. And I'm going to be videotaping it on the whiteboard. And so I'm just going to explain to you how I solved this problem. So, for part A, let's see, part A it tells us that we have a particle that moves along the x-axis, so that velocity v at time t is greater than or equal to 0 is given by this equation. Sine of t squared. That's the graph of, and that's what v is. This is the graph of vt. Equation, graph. Okay. So, with that equation, we are in part A, we are supposed to find the acceleration of the particle at time when time t is equal to 3. Now, to find velocity, or to find acceleration, you take the derivative of velocity. So, dv dt is equal to, and you take the derivative of this equation, which would be derivative of sine is cosine of the inside, t squared, times the derivative of the inside, which would be 2t. And then you always have to include dt. Okay, now it wants you to find dv d3 when t is equal to 3. So, a of 3 is equal to cosine of 3 squared times 6. So, a of 3 is equal to 6 cosine of 9. Okay? And now, most problems, they like you to just plug it in your calculator and find an actual answer. So, I am going to turn my calculator on. If it would focus. Okay, well, I'll get it sometime. And then I am going to plug in 6 cosine of 9, close the parentheses, enter, and you get negative 5.46678, or just, if you round it, negative 5.467. That's your acceleration. And Gordon, go away. Shoot. Okay, so I'm going to write it down here so that you guys can follow along the calculator. What you're going to do is you're going to plug in this equation right here. So, in order to do that, let's open up the calculator, and we're going to go to y equals, we're going to go to math, we're going to go over to number and see where it says ABS, click enter, and then inside the absolute value marks, you're going to plug in sine t squared, or I guess x, because there's no t. So sine x squared, close parentheses. Okay, and then before you graph it, you want to go to your window. You want to set your window, because we don't need all of that. All of that right there. We only need from 0 to root 5 pi, and then from -1 to 1. So, x min is 0. X max, let's make it root 5. Let's make it root 6 pi. Root 6 pi. And then x min is -1, x max is 1. Graph. Bam. See how it's all above the x-axis versus in the problem where it is above and below. This way, when we integrate it, we'll be sure that we're calculating the answer is not going to have any negative in it. It's always going to be positive. So, in order to do that integration, you're going to go to second, calc. You're going to go to number 7. It says integrate. Click 7. And then it says lower limit. Now our limits are the boundaries from the time boundaries. So it's going to be from time 0, enter, to time 3. And then it's going to color it all in and integrate it all. And that number down there, 1.705, is the answer. So you get about 1.705. Ta-da! Okay, now C, in my opinion, it's pretty much the easiest. C is asking to find the position. So let's do position is x. So position x, particle time t, when t is 3. So x of 3. It wants us to find. Now, going back to the beginning of the question, it tells us that we know the position of the particle at time t, and when t is 0. So the initial position is 5. So we know that when all of this up and down and all that starts, that's at 5, not 0. So, whatever we find the answer with, we just have to add 5. And then that is the real answer. So, let's find out what x of 3 really is. This is kind of like what we just did in the problem before, where we'd have to integrate velocity. But, as you probably know from the problem before, when we do velocity, when we integrate it, instead of doing, we want to find the position, so that's displacement, not total distance. And we know for doing displacement, no absolute value marks. So it's pretty much the same thing. We're doing from, our boundaries are the same. The boundaries are from 0 to 3. So, 0 to 3, and we're doing dt, but plus 5. Okay, so now we just have to figure out this part. And that, once again, can be figured out with the calculator. So, back to the calculator. Okay, so, go to y equals, let's delete those absolute value marks. See that? Just push delete, and they're gone now. Okay, now we're going to go to graph. Bam. Now, so that's the same graph that shows up on here. Okay, now we're going to go to second, calc, and 7. And our lower limit is going to be 0 again. And then 3. And see how it goes down? What it does is it takes the upper limit, and then it takes the upper part, and it subtracts the lower part. And that's the displacement. And that's why we had to do absolute value before. So the answer says 0.7735, so 0.774. So that's 0.774. That's still 5 because nothing happens. So we get 5.774 is our position at t equals 3. Ta-da! Okay. Okay, so for part D, they want find the time at which the particle is farthest to the right. Now, it takes some time to figure out what they're really asking here. Okay, farthest to the right. Well, let's think about a number line, a regular number line. We got -1, 0, 1, 2, 3. Okay. Now, when you think about it, which number is farthest to the right? Well, that's an easy one, right? The answer is obviously going to be 3, because it's the farthest one on the right side. Okay, so now this is basically, pretend that this number line is the x-axis. Okay, so it wants to find what time is a particle farthest to the right. So when is basically x a highest number? So when is x maxed? So we want to find the maximum of the position, right? So when is position max? I guess we'll have to figure that out. Okay, so whenever you hear the word max, min, you always think derivative of the next highest thing is what I think. So it goes position, velocity, acceleration. So I think x t v t a t. It wants the max right here, so we have to go to the next thing to find when it changes sign, positive or negative. Okay, so in other words, we are dealing with velocity again. back to that equation. Okay, so let's start on the problem now. Okay, so we got this velocity thing here, okay, and we want to know when that changes sign. So what we do is we set it, we can do two things. One, set it equal to 0 and find out when t is equal to 0. And then we do a sign analysis to find out when it changes from positive to negative. And that's a whole bunch of work that, truthfully, is not really needed. You do that, then you do a sign analysis, and then you find your points, and then you find, oh, positive, negative, positive, and then you find, hey, look, it's max. But that's a lot of work. So we're going to use the calculator because this problem allows us to use the calculator. Technology, you gotta love it. So just looking at this right here, you can kind of figure it out somewhat. Okay? Basically, you want to know when velocity changes from positive to negative. Okay? We know velocity is positive when it's above the x-axis. So that means here and there. Okay? So when it changes from positive to negative, it's going to be at this point and that point. Okay? Now we have to figure out what those points are. So what you do is you go to y equals, you go to calc, and then we go to the zeros, so number 2. I'm regraphing it so it's clearer now. Okay, so calculate 0. Okay, left bound. Okay, so that 0 right there is 1.772, which I happen to know from doing some calculating is root pi. So I'm going to write this down so don't forget. Okay? Now, let's just keep in decimal point form. Okay, that's the first. When it changes from positive to negative. Now the second one, calculate 0. Left bound, right bound is 3.0699. Okay? That's second. And that's where it changes sign. Okay, so when we get these two 0 values, we have to plug it back into x of t. Okay? Now, you might be thinking we never got x of t. But don't worry, we know how to do that. It's simple. X of t is equal to, you remember, 5 plus integral from 0 to root to t of the So, let's say x of 1.772 equals 5 plus integral from 0 to 1.772 sine t squared. Okay? And that looks like it's a lot of work, so I'm going to plug that in the calculator. And we get and when you integrate it from second Calc 7 from 0 to 1.772, you get point 895. Okay, plus 5, you're going to get 5.895. So that's one possible answer. Okay, we got to see if the other one is more max. So x of 3.0699 equals 5 plus the integral from 0 to 3.0699 of sine t squared dt. Okay, second Calc 7 of from 0 to 3.0699, you get 7.788. Then plus 5, we're going to get 5.788. So that's what you get with this one. That's what you get with this one. Now, you might not be good at calculus, but you can tell which one's bigger or not. Okay? It's this one. So, that means this must be the most max, or the farthest right. Okay, so it's going to be at when t is equal to 1.772. Okay. Now, just from knowing and stuff, since it's in terms of pi and stuff, and I know that is also equal to root pi. So if you did it with sine equals 0 and you found the t and all that stuff, you would have found this answer, not this answer. But either one works. So that's how you do part D. And it's pretty simple once you know what you're talking about. Okay. That's it. I'm done. Thank you.